Welcome back to this series on database development. Before we do any kind of a software project, the first thing that we hopefully do is create a specification for that project. Now, in a normal software project, that specification is going to include all the things that the program will do, might do, and hopefully will never do. A database specification is slightly different because the database specification is not going to include the features of the program. The database specification is going to be focused on creating a specification just for the data set alone. That is, the tables and the fields that describe those tables and then the relationships between those tables. So in this video, we're going to talk about database modeling and the tools that we can use to model a database. What we want to end up with at the conclusion is a database model such that I could turn it over to a developer, or I can use it myself, and then take and directly translate that data, the graphical data that we're going to create, into the structure of a database that'll work with the database tool that I'm going to use. The process of database modeling generally these days uses some sort of a graphical form to represent the data. We're going to create entity relationship diagrams that use geometric shapes to represent the entities, the attributes of those entities, and the relationships between them. It's an easy process, and it's one that works really well to translate back to the actual development process. So let's have a look at modeling. There are a lot of different modeling tools that we could use to perform this process, but we're going to focus here on something called an entity relationship diagram. There are a couple of forms of this, but we're going to focus on the more graphical side of this. There is a newer form of ER diagramming that uses tables to represent the entities, but we're going to use shapes because I think it's easier to learn. These geometric shapes are going to be connected together in such a way that it explains the nature of the association between the entities. We will take and use different shapes, the rectangles, ovals, and such, to model a data set. And once we've identified, say, we start with the entities, once we have identified those entities, we would then assign the different characteristics, the fields of those entities. So we have the tables, the fields, and then we'll use another shape, the diamond, to represent the relationship between the two of them. The nice thing about this in any of the modeling processes is that they can all be used iteratively. What that means is that if I come up with my first description and we go back to the users, we get the committee together and we talk about it, we find that it doesn't really align with reality. It's really simple to modify that model, and we can keep doing this, keep doing this, keep doing this until we have what we call in the database world normalized all of the data, and then we're ready to turn it over to the developer. So let's have a look at the ER diagramming tools. The building blocks of an entity relationship diagram begins with the entity. The entity is represented by a rectangle, and what an entity is a person, a place, a thing. It's that object about which we're going to collect data. So this is going to be the container, if you want to look at it that way. The entity will translate into the table within our database. The second shape that we use is the oval, and that represents an attribute. An attribute is something that describes the entity. In other words, these become the fields of our table, those things that describe each of the row of data that we contain in that's contained in the table. These attributes are the individual elements that combine together fully describe that entity. So we may have a ton of attributes, and we represent all of the simple ones by the ovals. Now there are a couple of specialized forms of attributes. The first is the key. Now the primary key is represented by the identifier within the oval being underlined, and that tells us, okay, that's the primary key. Remember that the primary key uniquely identifies a row of data. So it may be a single attribute or a single field, or it may be multiple attributes or multiple fields, whatever's necessary for you to uniquely describe that row of data. And the other specialized attribute that we'll see most often is something called a multi-valued attribute. That's represented by a double line making the shape of the oval. A multi-valued attribute is an attribute that can have one or many values, but they're all of the same data type. A patient may have one or more procedure codes. Now they all describe that particular patient. It's just that if I go to the doctor one time, he does one procedure. I go to the doctor the next time, I may get 3 procedures. And so we indicate that there can be one or many components to that attribute. Now, one of the things we want to remember with the multi-valued attribute is that it may turn out that that separates out into a table. And we would discover that through the process of normalization. If we're repeating certain things to support those attributes, it's going to be our process that we normalize out those items into a separate table of their own. Well, all of these elements don't stand on their own. They have to be combined together into a diagram that has meaning. And here we have a very small sample of an entity relationship diagram. The entity that we're identifying by the rectangle there is a student. And all of the ovals that we see connected to that student represent the attributes that describe each student. So the student ID, the name, the address, the telephone number, and on and on. Obviously there would be a lot more elements, but each of these describes the students that we're going to store in the student table. Now we see a student ID with an underline, and you remember that means that that is a primary key, and that will ensure that every single row of this table is absolutely unique. So perhaps we start at 0001 and go sequentially each time we add a student. That way, every time there is a student named John Smith, he will have a different student ID, and that will reinforce the uniqueness of each one of the rows in the data. Now, for each entity, we would create a diagram such as this on a separate page. If we were doing this on paper, we would create a separate diagram for each entity. It is not something that we can connect all the entities together and show all of the attributes for every entity all together. We do them on separate diagrams. I don't need to tell you this, but relationships can be tricky, and no more so than in the database world. Relationships describe the association or the ownership between two entities. That is, they describe how the two tables interrelate to one another. And they range in flavor from simple, a single to single or a one-to-one relationship. This entity has one of these or uses one of these, however it's worked out, to the most complex, which is a many-to-many relationship. So let's have a look at how those relationships are diagrammed. The first type of relationship, a one-to-one, is represented like this. We have the diamond in the middle, and that contains the action or the ownership of the two entities. So an employee is assigned a parking spot. We differentiate between the different types of relationships by the lines that connect the entity rectangles to the diamond. And you see we have two straight lines. This means that one employee is assigned a single parking place. And every single parking place is assigned to a single employee. So this is the simplest relationship that we can have. The next, and one that's a little bit more common, is a one-to-many relationship. You'll see that on the right-hand line that connects the diamond to the product entity, we have a crow's foot. And that tells us that that is the many side of this relationship. So the way this reads is that a product line contains one or more products. So our product line consists of 10 different sweaters. And so we have a single entity represented as sweaters. It connects to 10 separate sweater descriptions in the product table. So a one-to-many relationship. In the healthcare realm, we might change this to say a patient has one or more visits. And in that way, our MPI remains unique. We have a single MPI record, and it is linked through that relationship to the encounters or visits component of the data set. And that way we have a single MPI connected to multiple visits, and then we never duplicate any of the data within the MPI. And finally, the most complicated of the relationships is the many-to-many. You see the crow's feet on both sides of this relationship. And that says that one or more students registers for one or more classes. And likewise, one or more classes has one or more students. Now, this is a complicated relationship, and when we get into making business rules, especially for deletion, that this adds an additional layer of complexity. Again, going back to the healthcare realm, we would say that a patient has one or more doctors, and each doctor has one or more patients. Once we have completed the ER diagrams and they are satisfactory to all of the stakeholders in the project, we take that diagram and turn it over to the developer. And the developer can work directly from our diagrams to fashion the data structures necessary for the database management system that we're going to use. The entities will become tables. The attributes will become fields within those tables. Once those are created, the attributes then must be translated into specific data types. But once those are created, we fashion the links between those tables in whatever way that the database management system supports relationships, and we're ready to go. The database is then ready to be utilized, and we can use it in any number of ways. It may be the foundation of a larger application. It may be a processing database that we query directly, any number of things, but we'll have a look at that after we've had a look in the next video of how we actually would translate an ER diagram into a data structure. Until we get together again, good luck on your work, and we'll see you.